Hello all, in this video we can look at Laplace transform of a periodic function. First we talk about periodic function. Something in life occur over and again. Suppose we consider the moon for example goes from being not visible called a new moon into what is known as a half moon, then it becomes a full moon, then it becomes half moon, finally it will be turning to its new moon phase. That is, it will be repeated over and over again. Next example, consider the heartbeat or swing. We can see that repeats itself at regular intervals. So this type of function we call it as a periodic function. So how we'll define periodic function mathematically? So definition of a periodic function. The function y equal to f of x is said to be a periodic function if there exists a positive real number capital T such that f of x plus t equal to f of x for all x belongs to real number. That is, that will repeat the same function, that is f of x plus t equal to f of x plus 2t equal to f of x plus 3t and so on, that is equal to f of x plus nt, or we can write it as f of x equal to f of x plus or minus nt, n equal to 1 2 3. The least value of the positive real number t is called the fundamental period of a function, or simply we call it as period of a function. Example, the sine function is a periodic function with a period of 2 pi. So if you see graphically the sine function, from 0 it will start and pi and 2 pi. So this graph repeat again from 2 pi to 4 pi. So this is a periodic function with a period 2 pi. Now let us explain what is the Laplace transform of a periodic function. Let f of t be a periodic function of period t, then Laplace transform of f of t equal to 1 by 1 minus e power minus st 0 to t e power minus st f of t dt, and this capital T represent the period of our periodic function f of t. Let us consider now problems. Problem 1. For the sawtooth wave function defined below in the time domain, find frequency domain signal. That is, we have to find the Laplace transform of this function f of t, that is at by t, defined in the interval 0 to t. Since it is a periodic function, f of t plus t equal to f of t. If you see the graphical representation, so 0 to t, f of t equal to at by t, where it is a straight line from here to capital T. And this will repeat. So this we call it as a sawtooth wave function. It is saw name based on its resemblance to the teeth of a plain toothed saw. So now how you will find the Laplace transform of this sawtooth wave function. So we know that by definition L of f of t equal to 1 by 1 minus e power minus st integral 0 to t e power minus st f of t dt. Here our periodic function f of t equal to a t by capital T from 0 to t. If you substitute f of t equal to at by t here, a and capital T are constant. So you can take out a and t from this integral. So how we can write this means a by capital T into 1 minus e power minus s capital T 0 to t e power minus st into t dt. So this we have to integrate from 0 to t. Since it is the product of two function of small t, we can use integration by parts and find the integral value. So how you will do means a by capital T 1 minus e power minus st as it is, and e power integral 0 to t e power minus st t dt. Integration by parts means you have to consider small t as first function and e power minus st as second function. So first function into integral of e power minus st, that we will get e power minus st by minus s. Since we are integrating with respect to t, minus s we have to treat like a constant. So e power minus st by minus s minus integral 0 to t, derivative of the first function, t derivative with respect to t is 1, into integral of the second function, that is e power minus st by minus s dt. So this becomes a by t 1 minus e power minus st t e power minus st by minus s upper limit. If you substitute capital T, small t equal to capital T, we get this function minus lower limit equal to 0. So if I substitute t equal to 0, 0 into e power 0 by minus s, that becomes 0. Then minus this becomes integral 0 to t e power minus st by minus s dt. If you integrate again this function, you will get e power minus st by already minus s is there. One more minus s will come from the limit 0 to t. So what you will get? A by capital T 1 minus e power minus st into t e power minus st by minus s minus, if you substitute t equal to capital T, e power minus s capital T by minus s into minus s minus small t equal to 0, if you substitute e power 0 is 1, 1 by minus s into minus s is square. So that is equal to a by t 1 minus e power minus st t into e power minus st by minus s, first term as it is I will write. Then here you see minus minus plus and 1 minus outside, so you will get e power minus st by s square, and this minus into minus plus 1 by s square. So this you can write a by t 1 minus e power minus st t e power minus st by minus s, and this if you collect together, this you can write it as 1 minus e power minus st by s square. If I take this term inside, you will get first term into this. If I do a into t, t you can cancel. So a into e power minus st by minus s into 1 minus e power minus st. And if you multiply this by this term, you will get this, that is 1 minus e power minus st, 1 minus e power minus st will cancel, and you will get a by t s square. So your Laplace transform of f of t equal to a by t s square minus a into e power minus st by s into 1 minus e power minus st. Let us consider another problem. A periodic function f of t of period 2a, where a greater than 0, is defined by f of t equal to e from 0 less than or equal t less than or equal to a, and f of t equal to minus e from a less than t less than or equal to 2a. So this is a periodic function with period 2a, but you can see that this is not continuous from 0 to 2a. It is a splitting function. 0 to 2a it is e, and a to 2a it is minus e. So I need to find the Laplace transform of f of t and show that my Laplace transform of f of t equal to e by s tan h as by 2. So let us think about the graphical representation of the given function f of t equal to capital E from 0 to a. So I'll consider t-axis and f of t, then 0 to a, my value is, let me take here as E, capital E. So this will be parallel line, this will be the line parallel to t-axis, and from A to 2A, that is minus E, that is downward you will gain. So this is the line. So 0 to 2A, this equal to A and 2A, and since it is a periodic function, it repeats 2A to 4A, that is 2A to 3A, it will give you E, and 3A to 4A it is minus E. So this way we call it as a square wave. So we need to check the Laplace transform of this square wave. Here, the period of f of t is given as t equal to 2a. Then, by definition, we know that L of f of t or Laplace transform of f of t equal to 1 by 1 minus e power minus st 0 to t e power minus st f of t dt. That becomes, here, since capital T equal to 2a, you substitute here 2a, so you will get 1 by 1 minus e power minus 2as 0 to 2a e power minus st f of t dt. Since this function f of t is not continuous from 0 to 2a, we can use the property of integral and write 0 to 2a as 0 to a and a to 2a. So I can write my integral as 1 by 1 minus e power minus 2a is 0 to a f of t e power minus st dt plus a to 2a f of t e power minus st dt. So I know from 0 to a my f of t is e. You can substitute here e, and a to 2a my f of t is minus e. So we'll substitute, so you can write like this. And we know that capital N minus C, capital E are constant. So you can take out E from this to integration. So you can write it as E into 1 minus e power minus 2a is e power minus st by minus a 0 to a, minus you can take out. So this is e power. So here it will come minus only. There is no minus here. So e power minus s, if I integrate e power minus st, e power minus st by minus s, 0 to 2a. So if I take this e by some, now apply the limits, upper limit for t and lower limit for 0. E by 1 minus e power minus 2as. So if I substitute t equal to a, e power minus as by minus s, and if I substitute t equal to 0, so this becomes upper limit minus lower limit, so 1 by minus s. Then minus, so here there is no minus here, students. So e power t equal to 2a, if you substitute minus sa by minus a, and lower limit is a minus e power minus sa by minus s. So we can simplify this. How we will write e by s, all denominator you see it is s is there. So take out s. So e by 1 minus e power minus 2as. So this you see here minus minus plus. So positive term let me write first. So 1 minus e power minus sa. Then here you see e power minus 2as, and minus minus become plus. S already I took out. So this you will get e power minus 2as, and this you see minus minus, so minus e power minus as. So this, if I simplify, e by s 1 minus e power minus 2as, 1 minus e power minus s say plus e power minus 2as minus e power minus as. So this becomes e by s into 1 minus e power minus 2as, 1 minus, this you can write it as 1 minus e power minus as whole square. Why? 1 is there, minus e power minus sa and minus e power minus as, you can collect together and write it as minus 2 e power minus as plus e power minus as whole square. So it is of the form 1 minus e power minus as whole square. So this you can write it as 1 minus e power minus as into 1 minus e power minus as. And denominator term, you see, this is nothing but 1 minus e power minus as whole square. So this you can write a square minus b square form. We can write it as a minus b into a plus b. So this becomes 1 minus e power minus as into 1 plus e power minus as. So 1 minus e power minus as and 1 minus e power minus as will cancel. So you will get 1 minus e power minus as by 1 plus e power minus as. That you can write it as e power as by 2 minus e power minus as by 2 divided by e power as by 2 plus e power minus as by 2, or this is nothing but e by s into tan h as by 2. Therefore, the Laplace transform of square wave equal to e by s into tan h as by 2. Thank you.